Welcome to another Secret Spaces. This week we have Ethan Frey from Confio, as well as Asaf from Secret Labs and Erdman from the Secret Agency. You guys want to go ahead and introduce yourselves, starting with Ethan?
Hey, what's up? Nice to be here. My name's Ethan Frey. I invented CosmWasm. Started about 3 years ago on that thing and have been full on it since then. Before that, it's been another 3 years or so, since January 2017, in the Cosmos ecosystem, working on early versions of the Cosmos SDK, IBC white papers back in 2017, and lots of other tech out there.
Awesome. It's great to have you with us. Asaf, you want to go next?
Yeah, hi, I'm Asaf Morami, a core developer of Secret Network, working with Secret Labs. Super excited for today. Ethan is a person I look up to in the Cosmos ecosystem. Wherever I go, he's there. I always see your comments on all Tendermint issues. Whenever I want to implement something in our chain app, I look to see how you did it in WasmD. And even the other day, TS Relayer popped up for me on Twitter, and when I went inside, I saw your name all over the commit history. So, yeah, really excited.
All right, and Erdman?
Hey everyone, I'm Erdeman. I'm 1/6 part of the Secret Agency, helping them with doing several educational content, but also trying to help anyone on Twitter who's lost, helping them understand Secret Network. I work with Asaf and Secret Labs on creating certain tech content, which also includes the developer documentation. So if you have ever have any questions about the secret tech stack, the functionalities of IBC, then hit me up. I'm there.
Awesome. Great to have all of you with us. Before we get started, I want to mention we are distributing a secret badge for attending this secret space as usual. If you check the pinned tweet, you should see it in the space. There's a link in there to Stash, and that's where you can mint it. All you need is the claim code, which is IBC, just the 3 letters, IBC. And with that, I'll hand it over to Asaf, and we can get started.
So, Ethan, you've been called like the father of CosmWasm. So maybe just to start, I would love to hear like how CosmWasm came to be, like from your point of view.
Sure. Yeah, actually, I thank Misang for that one, that nomenclature. It was like the founder, inventor, she said father, and I thought that was awesome. So yeah, it was a hackathon. It was a hackathon in 2019, pre-pandemic, right after Cosmos Hub was launched. There's nothing really going on, no IBC, nothing, but the hub was launched. The staking is awesome. Let's build something. And it's this amazing hackathon in Berlin, and a bunch of CTOs, a bunch of companies came together. We thought we were going to make, Wasm smart contracts. That's a cool idea. Let's do it. And somehow we did it. So I got so inspired by the idea that I kept doing it. And also just the design of CosmWasm and the actor model, being able to integrate how you abstract the rest of the chain. All these design decisions we were making, discussing that, and I thought it was great because we had really a bunch of architects together in a room. And it was really more like, this is the SDK I want to build. I worked on the original SDK back 06, 7, 8. I went on my own SDK called Weave, which was full protobuf first, and whatever, client proofs and stuff in JavaScript clients, before CosmJS and everything. It was this, written out in 2017, 2018, 2019, which I liked and it was practical, but it's still, I felt like CosmWasm for me felt even better for composition. It was really this beautiful composable mechanism. And I enjoyed it very much as infrastructure, as design, as building it secure first, but super composable and modular. So I really just enjoyed it and just have gone full in that and dedicated myself, quit all of my jobs and said, I'm going to build this, even if there's no funding. And eventually funding came.
Wow, that's really cool. So, at the end of the hackathon, what was there for CosmWasm? What was working, what was not working?
Well, we could compile a contract. We wrote a contract in Rust. It was able to receive tokens and send tokens. It was a simple escrow. You would set it up, and you would set, arbiter and a recipient, and you send tokens with that. And then at some point, the arbiter could either return the tokens to the original sender or give them to the recipient, right? And so we had that creation of a contract. We had uploading the code. The code size was about 2.5 megabytes at that point. We didn't figure out how to optimize it. We could upload it, we could instantiate it, multiple copies, and we could call this contract. And we had a UI for it. So yeah, Yehan from Theo is working a lot on the Rust stuff. I worked a lot on the Go stuff. He much better Rust knowledge and factored out that a lot. And Pablo from Wallet Connect was also on the team, and he was knocking out UI, which is awesome. And then we even after we submitted it before the presentation, we decided to go make another contract. So we modify this contract and upload a second contract. It was just like a cut and paste stuff there, but it was cool. It was cool. We did some changes to it, and it was cool to see we could actually knock out an hour. But it was simple escrow contract. I was able had most of the functionality. You could have built CW20 with that stuff we had basically. Everything was raw storage. We didn't have any fancy wrappers around storage or anything, but we had the raw byte storage. We had no queries. You couldn't call into the modules, and the only thing you could do is was basically call other contracts, I believe, and move tokens. But that's plenty to start.
That's really impressive. I know the internals, and there's a lot of code with memory management and stuff like that came into that, I'm sure. And in just a few days, that's really impressive. And also, it's funny because we are still using the escrow contract in our testing. Like RCI uses that escrow contract for some tests. So yeah, that's funny.
Yes, my CosmWasm contract we added on there, the HackAdam contract. It's there. It's gonna stay there forever, I think. But it's the basis. It's the basis of everything, kind of. And I mean, the reason we cut corners there's no gas meter. You get infinite loops in our code, right? There's no restriction to anything. It was it worked, but anyone could brick a chain so easily with that one. The main thing we did is that we cut corners. We didn't have our own FFIs. Later, we had to build our own kind of Rust library with lots of custom callbacks and do integrations much nicer, and have gas metering there, determinism checks, all these other checks in there in the Rust code, tying and customizing the Wasmer VM. At that point, we used simple Go bindings I had, and it worked. It worked somehow. There's some memory leaks in there. There's no customization. There's no gas metering on it. But yeah, I mean, it ran. So it was definitely, we had to go a lot further to productionize it over the next year. But I would say even by, I was dibbling it a little bit for the part of 2019 learning it. Then 2020 is really when full on 2020. I had something kind of working, and then in January 2020 it went full on, and by September you'd launched it on secret. You'd not only just launched it, you'd actually ported over to the trusted enclaves and launched it, I think, or maybe it was October. Tara had it in September and you had it in October, I think, or September, and that was pretty impressive for me. See these two chains actually go live within a year, basically.
Yeah, we had it on September, and then Tara went, I think, 2 weeks after us. I don't even know if they did anything. They just I think imported your code. But yeah, we rewrote the Wasm engine to work inside SGX. So yeah, it was a lot of work and was very cool when it finally worked. So yeah, thank you for that.
Yeah, totally impressive. Totally impressive. So what you're doing now is this 1.0 upgrade. I'm very excited about this one. So I know you guys like the OGs in the space. In fact, probably the last man standing, I think, in the in the CosmWasm space. I know you customized your own VM there and using WasmI and stuff like that, which is cool. But you're actually compatible with CosmWasm contracts. So all these other contracts out there can use it, the same SDK. The contracts themselves run the same way. I think minus iterator feature, which is optional in a lot of these things. So but yeah, it's really cool. It's really cool that it's actually as compatible as possible. We spent so much time to actually remain compatible, and now we have 1.0. Use all these new contracts out there. It's basically opening up to using these out there. So I'm curious about you. Is it fully compatible? Can I just basically take my? Do I need to change anything, or a little bit, or can I just take my CosmWasm contract from Juno or from Stargaze and stick it on secret and suddenly it's a private contract? Yeah, does it work just like that? And yeah, what are you excited about seeing coming over to secret?
Yeah, so we do have WasmI instead of Wasmer, and we try to keep all the APIs the same. But I think there's one thing that we couldn't hide from the contract. which is the when you call another contract via a submessage, you also need to know the code hash of that contract because we use that in the encryption scheme. Like the code hash of the receiver needs to be used in the encryption in order to make sure that like the receiver contract is the only one that can decrypt the message. So when you call another contract, you also have to specify the code hash. And then, yeah, there's no iterators, which I think was a mistake. And we are going to implement it soon after the V1 upgrade. And then there's also no contract migration, which we are also going to implement soon. But other than that, yeah, I think you can take like a Juno contract and maybe with minimal alterations, run it on secret. Like obviously, I think iterations is a big like feature, and a lot of libraries use it. So that might be challenging to like port those libraries without the iterations. But yeah, it's like I think 98% compatible, 99 maybe.
Cool. Yeah, I mean, the iteration, if people know are listening in, what it is right now you can just read, if you have a key, you can read the value, right? Like if you say show balance to this person, you can find it. But if you want to walk over all balances of all people, for example, that's called iterator. And some things, and you can do an order, ascending order, descending order, scan it. It's basically a prefix scan in a database. Ethereum doesn't really let you do that and tries to hash it. So you can't actually iterate over space because you only can iterate over hashes. And that doesn't make sense anymore. So for example, like Ethereum tries to not allow it, but IVL tree does. So we actually left it a feature in the beginning because the original design of CosmWasm is like, I wasn't even sure if the SDK would pick it up, if people would pick it up. So we like made this VM that could be plugged in other places. And so kind of anything that was not, generic blockchain, we kind of left as a feature, a flag that you could turn on or off, right? So by default it's on, but you can turn off iterators. A lot of chain projects don't need it. So CW20 doesn't really need it, right? When you transfer tokens from A to B, you just need to my balance and your balance, and we adjust them, right? We check one singleton, which is the config. So those type of things don't need it. And there's, kind of a nice query, show me all my tokens. There's more complex contracts out there, like the DAO voting contract. That's actually one of the coolest ones I think out there. I'd love to see you guys playing chain. And what it does is it takes snapshots often of the balance. So if you want to say, hey, we implement a lot of very, very powerful features using iterators. For example, if I want to say, show me the historical balance of this address at this time, well, I could go through at that time. I say, I'm going to take a snapshot. I could take a snapshot and copy all the balances of everyone over into another data structure and keep that for the future, right? That's really expensive. It could be thousands or millions of reads and writes, depending on how people. And that's like, you can't allow arbitrary blockchain. You can't do order n stuff, only order one, constant type, right? So what we did and how we implemented that was it wouldn't do anything. It would just maintain from that point in the diff. So if you change, so I take a snapshot at time X, and if I change that value after time X, I will store a diff there. Say at height 17, height Y it changed, right? And if I want to find the value at time X, basically I say I will iterate through those changes from my current height backwards to that height. I will find the most recent change if there was one, which is the new value, right? Or if there was not, or no, I said the latest change, the first change after that height between mine. And if there was no changes since then it was actually the current value, right? I find the first change, and if it wasn't one, there's the current value. So we actually have to use iterators to do that. So it's a very lazy snapshot, I call it. I think it's a very, very powerful data structure, but it does require iterators. And so it's not iterators you think of, it's under the hood completely, but it's actually, I think, very powerful one for voting. So yeah, I'd love to see that. I don't know if that's possible to iterators here, but that's really like that one thing, the snapshot map and secondary indexes, which kind of need it.
So yeah, it's totally possible. Our logic, like back in 2020, was that using iterators, the contract can expose like data of other users, but that logic I think was flawed because like if you're the contract or if you're the contract dev, you can implement it however you want. Like so, yeah. We're gonna implement iterators. I think the major issue right now is that our encryption scheme like did not take that into account, so maybe it's going to be harder to implement like ordering of keys and stuff like that. We'll figure it out. But yeah, it's totally possible on Secret.
Or you could come up with another implementation of snapshot map that doesn't require iterators. You have another trick that doesn't use iterators, and then you can just drop that in like some compatible map, and then other people use it. Because that's really, I think, the biggest use of iterator scene. There's a lot of helper queries. A lot of people have helper queries that use it, which are totally optional query helpers, right? Like, show me all of these people, right? Iterate over them all. Show me all the proposals, which is not needed. It can be done in an off-chain database. It's not actually needed for the logic. It's needed for clients. But snapshot map and secondary indexes are the ones I see that are actually used for the main logic. And so the other way of just basically implementing other implementations of those using your encryption scheme. But I feel like once you have those snapshot map and the secondary indexes, even the different implementation of them that has the same API, you'd be able to really get a lot of those contracts out over there. I mean, more powerful ones. So the simple ones don't need it all, and the more powerful DeFi ones and those DAO contracts really do seem to use them.
Yeah, that's a good feedback. Like, my thinking is that we wanted iterators because we want to use like libraries that are written for Juno and Terra without rewriting them without iterators, like to reach feature parity with them. But that's a good feedback. Well, I'll take a look at like snapshot map. Thank you.
It basically they change it. You have to change the code anyway a little bit. The change you go into state.rs and you change it from import CosmWasm plus snapshot map to import secret plus snapshot map, for example, right? And suddenly it's one that doesn't use iterators. For example, if you that might be an easier way, right? Just not you wouldn't allow everything. You wouldn't allow some helper functions, but a lot of this stuff is indexed on clients anyway in like backends. But anyway, I want to go over to IBC. So I think iterate is one thing I see that I really see like with that you have full feature parity with those things. But I think IBC is really cool because so far you've basically had a token IBC, right? Like, so I think one of the biggest use cases of Secret, as I know, is I will have a token on my chain, Juno, Osmosis, Atom, whatever, and I say I want to swap it with privacy. So I'm going to send it over to Secret, and then there's this snip 20, I think, and then when you're in snip 20, you can stick in a DEX, right? And so maybe you can go into that one. How using IBC now? It seems like right now is you can kind of take assets from other chains, put them in Secret, and then some kind of secret network, and then kind of like secretify them, right? Like, so maybe you can explain how that's working now, and maybe how you like to see this evolve in the future.
Yeah, so SNP20 is like our version of CW20. It's a token with private balances and transfers. And up until now, we had like only the IBC transfer app. So you could send like Juno, Osmosis, or Atom to Secret and then wrap it as SNP20. And then you get like private transfers and balances on your like Juno, Atom, Osmo. And then we got like that feedback from different groups around the Cosmos ecosystem that they are using it to do payroll. Like the employer will pay the employees using the secret token version of like Juno, Atom, Osmo, and to not reveal their salaries.
That's a very cool use case, actually.
Yeah.
I'm thinking, a lot of things you're like, if I'm trading on a DEX, I'm not really that worried about privacy and stuff like that. A lot of places, but yeah, if you're paying like employees in generally people are saying, hey, we don't. Some places are fully transparent. Some companies are, but a lot of companies don't want to show this out because some people want more employee who everyone's like fighting over salary, kind of, right? So if you do pay your employees in crypto, it's completely transparent. Maybe you want that, but maybe you don't. And so like, there's no other way of like, obviously all the employees know your address. They see who's sending to who, and they see all the other employees' salaries. So it's actually cool that everyone can pay privately and they can withdraw when they want to, whatever size they want to. And yeah, that's a really cool use case.
Yeah, thank you. And then there's also like we have DEXs on Secret and you can trade on them. And the first, I think, version of DEXs on Secret didn't really have privacy, but mostly front-run resistance because inputs are encrypted. But I think we're getting a second version of DEXs, like in a few months. There are a couple of DEXs coming with cool privacy features. Like, I'm not sure I'm qualified to go into details, but yeah, on Secret you can implement like privacy features for DEXs, and that's gonna be really cool, I think.
Yeah, front-running resistance is a big one too, definitely. One thing is just keep it known who's trading what, but another one is saying basically the no knows till after the block is committed who traded what, right? So no one's running your stuff. I think for me, IBC contracts is huge. So if you saw me at Seoul or any of the talks I did in Korea, you would have probably seen me just blathering on about IBC, from explaining how to build the contracts and how they're built, to the future of the interchain, to how to compose and what multi-chain composition means for new protocols in competition in the interchain space, at Build Asia, for example. So I've been really, really hot on this. I mean, I got red pill on IBC the end of 2016 and have been kind of waiting for that one. And now this has really come out there. So it's not just ICS 20, it's really like interchain accounts, interchain queries, and CosmWasm contracts. So I'll just give you a brief overview of where I'm coming, why I think it's amazing. So right now you can move tokens, which is pretty cool. They have bridges too, right? But this is allowing arbitrary contract calls. So interchain accounts lets you like call another contract on another chain, basically, right? So you have another account. So I have either it's a DAO, for example, on my chain, or even a liquidity, a DEX maybe wants to do something else, and maybe the DEX decides to, whatever, balance its protocol by swapping on different DEX. I don't know, whatever. It can do something on another chain, right? Any account, any contract can control an account on another chain, and it will send a message to the chain over interchain accounts, and it will be executed over there and get a result back. So there's some issues in usability. It works, it's implemented. There's issues in usability, especially in composing it. It works well for the state where you're doing like manual governance on it, but if you want to compose it and actually stick into workflows as a primitive in higher order contracts, there's some issues like lack of callbacks. Like you don't know if it failed or succeeded on the chain. You have to actually have an off-chain client watching it to see if it succeeded or failed or when it succeeded. So it works fine for like the governance DAO use case maybe, but not for these other more complex ones. So I was going off on like how you can make this better, right? And so I've had discussions with the teams technically, but also just imagining how you could iterate it. And I found the problem with IBC is they've been very methodical. They've been very good primitives. These are very, very solid building blocks. It's wonderful foundation work, but they're not a product team. So the IBC team has built these amazing foundation products which are super stable and strong, can build on top of them. It's not going to fall down under you, not like these other bridges that fall and get hacked, right? It's like this super stable foundation, and they build pieces as super stable foundation, not as products and not in product lifecycle, right? But if you say, hey, they do 95% of the work, I actually only want to do the last 5% on top. We can do as an app logic. That's a whole other speed of development. And I really think that's the future for multi-chain applications. So what you can do with contracts now, and this is, we've been able to do this for about a year now. It's only was interesting when you have multiple CosmWasm chains, really. So there's you can launch a CosmWasm contract on a chain that speaks IBC directly, not like just using ICS 20 transfer. It speaks its own protocol, and you can launch a contract on, right now, Juno and Osmosis, for example, and they can have their own protocol, their own packet format, and speak back and forth. They can talk to each other. And so with that, I built interchain accounts as two contracts. One contract calls another contract, right? And it's a different wire protocol than interchain accounts with the same functionality. And then we said, hey, let's add some stuff to it. And it was really cool to see in Seoul in the hack at him. I showed this to Jake Hardell from Juno. He thought this was awesome. And in the course of that night sometime, I don't know, 3 a.m, we're looking at stuff that he was, started sometime at dinner time at 2 or 3 a.m, we're looking at stuff. He had callbacks working on it, right? So when it returned, the acknowledgement came back, it called back the original caller. And he had interchain queries working cross-chain also, right? I went through later. It was definitely a late night hack. I went through that later, probably another day on it, cleaning up some stuff and adding the full tests. The thing is real wonderful work full JavaScript test case, which is actually bringing up multiple nodes and running JavaScript test cases of actually this whole query stack working in real node environments. So I got that whole thing, properly tested and a little more cleaned up. But it's wonderful work. And you think about it, he knocked out for the first time in a day, and I spent another day on it. And we have we have, callbacks, and we have interchain queries working on top of it. So the level of speed, and of course, don't take that code and put in production right now. You want to review it. You need some reviews on it. But the level of speed of development is such orders of magnitude faster. And that is meant for products. You clearly need to have reviews. You clearly understand this stuff and review it afterwards. But even getting 3 people to audit it afterwards is faster than kind of waiting X months until some team, which is really a infrastructure team, delivers something for your product, right? The product team needs to own that product, right? So I'm thinking, I say build as much as you can on these primitives they give us, right? Use the primitives they give us. And if you want to do something product specific, you can just write your own contract to speak their own protocol. So I'm really curious to see how. So this is I'm hyped on this, right? I think there's a whole lot of stuff you can do with this, right? And whether it's just a DAO swapping on a DEX in a different chain to like a lending protocol actually running on 2 different chains, splitting liquidity between the 2 chains. I don't know. I think there's lots of stuff we can do there. And now when it comes to secret, you don't just have like just another chain that's more or less identical that might have different protocols there, but has actually fundamentally different attributes, like the privacy attribute, right? So actually, maybe I'm architecting some sort of protocol, and part of it is a bunch of DAO, something I want on Juno because I like their DAO stuff, and part of it I want Osmosis because I want to integrate really tight with their DEX, their AMM. And maybe part of it I put on secret because I want privacy about this part of it, right? And I can architect now my kind of application on 3 different chains and just connect them with my own protocols. So I think this is like this space, a huge space of design, which is opening up now. I'm super hyped on it. I'm trying to help people learn how to build these things. I think is a huge problem. First, architecting, designing protocols, and then implementing it. Implementing, I think you can pick it relatively quickly, but the whole design architect of it is quite a bit still. So I'm really stoked on that one. And I think one of the big things there is understanding what you can do with it, right? What you can do with it. So I'm really curious of how you see secret contracts working in this world. Like, what protocols do you see in secret working, and how do you see them working on other chains where like the actual messages sent to the chain is not going private, of course. So and how do you get what parts go in secret, and how that privacy boundary will actually be able to use and compose these multiple chain applications.
Yeah, like what you said really resonated with me. I guess I'm hyped too about IBC contract. Like I guess our first use case that we discussed is offering like random number oracle on secret, because you can store like private state, you can store private entropy, and generate random numbers on secret, and then offer that through IBC contracts to the interchain. Same as how Chainlink works on Ethereum. So that's one use case that we are discussing. Another one is, you mentioned it, like offering private voting, for example, for DAO on Juno. So how that would work is that there will be a private voting contract on secret that just tally the votes and reports back. And then on Juno, the user will encrypt their vote on the client side, and then broadcast it on to the DAO contract on Juno, which will just relay the encrypted vote to secret via IBC, and then on secret, the contract will tally the vote privately, and then at the end of the voting period, the DAO contract on Juno will trigger a tally, which will then report back to Juno the final result, like yes, no, or yes, 60%, no, 40%, or stuff like that. And I think that's a really, really cool use case, especially in Cosmos. On Secret, we have private voting for the CFI DAO for like over a year now, I think. And the votes are really more balanced compared to the votes on like native Cosmos chains. It's more like 55-45 and less like 98% yes, 1% abstain, 0.5% no, or stuff like that. But yeah, I guess there are a lot more use cases that I'm forgetting.
Should I add some?
Yes, please.
I think just to quickly mention, like what Ethan here was mentioning is basically a chainless protocol. Like imagine an application which is launching not on any single chain, but it's launching basically on IBC. And we see this coming already with some applications. I think Mars is doing it, and some of the liquid staking protocols are also thinking about launching on every single blockchain that enables IBC. So this is really going to bring cool things. But maybe to get back to some quick use cases, one could also think about private liquid derivatives. So currently, the only tokens or the only coins actually that you can bring to Secret are native coins. So you can bring Osmo, Atom, Juno, basically all those layer 1 coins. But after this update, you would also be able to bring in tokens. So CW20 tokens can come onto Secret and be their own SNP20. So there are two options in which we can bring liquid staking derivatives for the entire Cosmos, but private to Secret Network. Either, for example, Quicksilver or Stride could one-on-one integrate with Secret Network and say, hey, all our derivatives, we will actually issue them on Secret. So even though the entire minting logic is not launched on Secret, what we do is we transfer the tokens immediately to Secret Network, and you can get them there. Or we will have a separate account for you that controls them on Secret. And that way, all your tokens, all your liquid derivatives are actually private. And the other way would be if something like a Shade or Polymer Finance or another DApp on Secret Network actually issues their own liquid staking tokens for maybe Atom or Juno, they would immediately inherit all of the SNP20 privacy details, and you would have a private way to stake your tokens, which is not really possible at this moment on any other Cosmos chain. So I think that is really a cool use case as well. And I think then, as I've already mentioned, you get private voting, but one that is often, I guess, sort of not completely understood or not thought about. An interchain DEX aggregator will be here very soon. I can't imagine the liquidity on Osmosis, Juno Swap, and Secret to be still for much longer. But there will be an app which just simply calls contracts to all the different chains and uses all of their liquidity at the same time. So I'm really looking forward to chains going. It's not really per se a privacy feature, but to make sure, or basically to implement aggregated order books or aggregated pool liquidity across IBC, which will make the trading experience for all of us probably a lot easier.
Awesome. Actually, that's a nice breakdown there. I just was on a call yesterday afternoon with a DEX aggregator, which is spreading on multiple chains, and asking me how to orchestrate the interchain accounts, right? They have they're running on multiple chains within that chain, but let's figure out how to aggregate over multiple chains and how to do that. And actually pointing out some issues in the current IBC protocols that don't work with it, right? Like you probably want a one packet swap message. You don't want to say move token, wait, try a swap, see if it worked or not, ask to get money back, right? Like that's too slow for your DEX aggregator, right? They might have moved too much. So you really want that one token swap, I think. So we were discussing various things there. So it's, I think definitely coming there. I'm sure multiple projects working on this right now. And yeah, like I said, I'm having orchestrate it. And speaking of native multi-chain stuff, so besides doing infrastructure, I'm also launching, co-launching, whatever, I'm one of the founding team of Wind DAO, WYND, Wind with a Y, DAO.com. And it's basically a DAO on Juno. and we're looking to basically is a DAO that should be controlling many things on many chains. It will launch multiple DeFi products on multiple chains and connect them, and ideally we'll have something secret as well, right? So I'm looking at how to orchestrate that and how to do that. So we're discussing that right now, and right now it's basically just optimizing the governance, the token distribution stuff so far, and then how to do it. If we launch a protocol on another chain, how the governance live on one chain, the protocol of another chain, how do you handle the updates to it, the revenues, how does stuff like that work? How to integrate these two protocols that want to be integrated between chains. Do you move the token and then do it there? Do they integrate how? So I'm definitely working on that, and I'm really, really excited about that. I've seen what Mars is doing with some cross-chain accounts. A lot of these are doing them. I see they're doing the first step, basically, of using interchain accounts to control another chain. And I think I definitely want to go a few levels beyond that one, and also take advantage of these features. So it'd be awesome to say, hey, this has a staking derivative on Juno, and it has some native a DEX thing on Osmo, and have a privacy feature on Secret, and really integrate those together into one coherent application rather than just independent applications. So yeah, I'm working on that, and if you're curious about it, check it out online. We're definitely we had an airdrop. We are launching the DAO in a month or so, so it's coming up. But it's definitely for me in a way of like applying this theory in the real world, and I'm sure a lot of people are applying this theory, and I'm talking to a number of teams doing this. So it's really, really exciting space.
That's really interesting. Like the plan is to have a set of contracts on Juno that control other chains. So for example, on Secret, you can use interchain accounts and IBC contracts to talk with them, and on other chain without CosmWasm, you can use interchain accounts. Like, is that the plan?
Definitely, we're focusing mainly on CosmWasm chains first, where we can write our custom protocols on both sides. We support Atom Legacy, and I don't know there's much there except staking derivatives, really, right? So there's probably some support for doing that there, but there's not much on Atom really. So like, what do you compose with an Atom, right? It's not running, like you're taking off the DEX off of it, and they'll have ICS, which you can't really invest in, so staking on it, right? So there's not many apps on it. So we'll probably do that to lower in the priority. Everyone else wants to stake Atom, right? But like, I'm really interested in CosmWasm because you can do it more interesting. When you have CosmWasm on both sides and the contracts on both sides of the IBC, and you can evolve that protocol, you can do all kinds of interesting stuff. So I gave an example before on the episode center a little while ago, and it's really like a DEX. So we're not building a DEX. I'll just tell you straight up. Wind Protocol will not build a DEX. There are too many people building DEXs. I'm not competing with anyone in that DEX space. We're not going to build any DEXs. But if I were to build a DEX and I wanted to multi-chain it out there, and maybe Osmosis is hearing this and goes, "Haha, we're doing this now." They or GeoSwap or someone else. Like, so if you have a DEX on a chain, it has a lot of liquidity, right? But you say, okay, we're going to go multi-chain. So you launch a second DEX on a second chain, and it has very little liquidity. You have your brand name, right? But you don't really have any other liquidity. So how do you handle that, right? The price is wrong. So imagine this: instead of building like interchain accounts, it's like we're going to actually build a branch. We're just not doing a copy of it. We're building a subsidiary branch on chain B, right? And so the parent DEX will launch a subsidiary branch. Now that branch is actually controlled. They have their own authenticated protocol that communicates between these two chains, right? It only is between the parent and the child. Not any arbitrary user, just the parent and the child have their thing. They say, okay, this contract, this one connection, one channel is made, and we trust this one channel. The parent can then send tokens down that to the child, right? A small percentage of liquidity and price feeds. So while the price is relatively stable, you can move like 1% or 0.5% of liquidity of the parent onto the child and give a price feed of what the proper price is. And the child can basically trade at that price with the small slippage in that little 1.5. You can calculate, basically the parent has X and I'll just have, the little difference on mine. You can do that. And as long as it's relatively stable, it will actually work. You will get the slippage of the parent chain. It will net out every, minute or so between the two of them. And you will basically get the benefit of using a DEX with effectively super high liquidity, right, on the child chain. But you'll be able to trade more than 1% of the total liquidity in a swap because we have only some there. But as long as you're trading within 1%, you will get the slippage and the low curves and everything as if you had the huge liquidity. If there's a big run, well, people run, the price drops, people run to one end, it just runs out of liquidity. And then it waits till the parent updates the new price feeds, it does something, and it will balance liquidity out later. And then you get new prices. So you will stop a run because it doesn't have much more money. And so you can do that. And so mostly you will basically immediately be able to say, hey, I have my DEX with lots of liquidity on chain A. I will make a subsidiary on chain B, which is access effectively to all the same liquidity I have on chain A, right? It means that parent will have to trust the child will have to trust the parent, right? It's a two-way relationship of trust there. And they're not just two non-trusting protocols, actually one protocol that's effectively running on two chains, because the trust boundary, IBC is not the trust boundary. Often you say, okay, I am one account on chain A talking to another account on chain B, and they're foreign things, right? There's a trust boundary is the IBC boundary. In this case, IBC is inside the protocol, right? So there's no trust boundary there. It's actually like trusting the other side is me. I am the other side. It's just like if I have a protocol made of 3 different contracts calling each other, they trust each other, right? Oh, this is the admin contract. They can do what they want with me, right? Like we're multiple contracts making one DAO. So clearly we're trusting each other. But then these other external ones are not part of the DAO. Well, we don't trust them. They're limited what they can do. So I think there is this huge potential there, actually, I think. And this is really what I look forward to once we figure out how to go beyond token transfers and chain accounts, is really saying, let's make these protocols are kind of authenticated protocols. So we have, one protocol that spans 2 or 3 different blockchains, and it actually, like, parts of the contracts, they're calling other contracts a part of themselves, basically part of this one protocol. And the trust boundary, one application basically is running parts of the application in different blockchains with a trust boundary, not in IBC level, but like with the user interactions on different blockchains, and IBC is fully trusted. So I think there's a whole other way of architecting applications.
Yeah, wow. So as long as you trust both networks, you can say that the app is secure, I guess.
If you assume, first of all, that we've audited both contracts on both sides, and they're by the same organization, makes them both, and you should audit them both. And that's, of course, either contract is hacked, same way as if you have 3 contracts in your lending protocol, if any of them get hacked, your lending protocol is hacked. And if either chain is hacked, yes, then you're broken. So you probably do want to make sure that both chains are stable chains. But those are both, the chain hacked is a pretty far-fetched one. I see more of the code hacks happening, So yes, you want to be a little careful there, but I think it's definitely and normally it's a little bit of risk there, but generally, as long as you do a proper auditing and a little more auditing than you would in a normal application, I think it can allow a whole new class and whole design frame.
That's a very, very cool idea. Like having an AMM with branches on other chains. Wow, that's cool.
Hey guys, let me interrupt real quick. Sounds like a good stopping point, maybe. This is usually the time we open it up for questions from the audience. So if anybody in the audience has questions for Ethan or Asaf, go ahead and start raising your hands and we'll get you up on stage. But in the meantime, you guys keep talking.
All right, yeah, happy to hear questions, especially if I should explain something again. So in this thing, I'm really thinking about this is my framework, my mental model I kind of explained, right? So that's what I'm building out there. I'm building tooling for it. I'm happy to help anyone, build this stuff out there. I'm using WinDAO. And one thing I'm thinking of is how you'd build these things, right? So this branch model is one idea. And so I think really moving parts of it to the place they belong. So like if I have an application, I don't need the whole thing private. Maybe only part of it private. So I like your idea of the voting app, really. I like that idea a lot. I think that's amazing. So if you just have like the voting aspects of it private, and maybe this is part of it, maybe you'd actually have like a sub DAO. The Wind would say, hey, we have a sub DAO that allows private voting on Secret Network, right? And then we trust that fully. So basically we'll have full control. If that decides something, it will then be treated as a full vote, right? So you might be able to delegate some voting modules. There's actually this really cool thing in the DAO stuff, V1, you have multiple voting proposal types, right? So you could have, like, for example, a proposal or multiple choice proposal, ranked choice proposal. You could have a gauged proposal, and they all basically, if any of them vote on something, they could execute a transaction with the same address. So you could actually have maybe like the public vote and the private vote thing, that certain aspects will be controlled by private votes, which is actually very interesting, especially if it's like, controlling multi-sig. Like, so if it's not like, okay, who thinks we should, launch a stable coin on this channel, or who will think we should launch an Oracle service, or what, right? Like that's, maybe it's public is good, but especially if it's like censoring someone, saying, hey, who's appointing the people to this chain, to a subcommittee, who thinks we should withdraw their powers here, or like make critical things, especially things that are like popularly unpopular, like revoking someone's permission or removing some protocol or blacklisting something. Maybe that should be a secret vote. So maybe that'll be like have one sub voting module that would run secret for the secret votes. They're needed as secret. We think of these important things we want to keep secret, we put them over there. And I'm trying to wonder what other things. You mentioned the token swap thing. I think that payment is a really interesting idea of having like the outgoing payments actually managed in secret remotely. So I'm trying to think how that'd fully work because if you use an account, that message is not encrypted or how you encrypt it. So I'm trying to architect it, but I think it's definitely cool to say, hey, these fragments of our large application vision should be secret, and we just put them on a different blockchain, no problem. And we have this extra power. But yeah, I'm not sure. How do you see moving secret stuff across things? Like if I have a DAO on Juno that wants to pay out a bunch of people and keep them secret, those secret payments can happen on secret, but how does it communicate it? It would actually have to like encrypt the payment instructions off chain and then vote this encrypted blob on Juno. The encrypted blob then gets sent over the wires IBC encrypted blob, and then it was received on secret in that one. It can basically be decrypted and executed in that trust environment, or how would that work in your mind?
Yeah, kind of. You just can't have the private information on the sending chain. So if we're speaking about Juno, you can't have like the payment info on Juno. You have to encrypt it before it reaches Juno. Otherwise, it's not private. So you somehow have to encrypt it off chain and then via Juno pass it to secret to fulfill the payment. Yeah.
In my mind, there are two options, I think. One is what you already proposed, which is what if we make a trusted setup where we encrypt the data off chain, but the contract on secret is in the know on what is going to happen or what the encryption key is. So then on chain, everything would be private. But off chain, there is someone who knows what is going on because they have access to the key. And another way to potentially do it, which is I think something Penumbra is actually working on, which is setting up sort of a batching contract. So you would be able to, if enough users want to pay out people from Juno via secret, and they don't mind the exact timing on when this payment is done, what you can do is do something. It's similar to Tornado Cash, but a little bit different in the sense that you can send all the info to secret, and on secret it will just wait for an arbitrary amount of time. Or even better, you send a code with the information on Juno to say, okay, hey, you can claim your tokens later when enough time passed. And then when enough time passed, so your anonymity set grows over time, the user can go back and claim it again on Juno, but it will come via secret. And as long as this code never reaches the on-chain situation, which should be possible using sort of relay or operator structure, you actually gain a transactional privacy protocol, which is working on Juno, but it's leveraging secret. But the timing part is here very important, because otherwise chain analysis would reveal that one user on Juno sent something and then another one got something. You can estimate the amount of time it would take to pass through secret, and you would potentially know what is happening.
So I think when you incorporate privacy features into your app, you have to first think of the privacy model. So for example, if you want to do private payments, you need to decide first what's private, like the amount is private, the recipient address is private, the recipient identity is private. So for example, if a DAO on Juno wants to pay Bob, I don't know, 10 atoms. So maybe we know the identity of Bob, which is Bob, and the amount, which is 10 atoms, but Bob can encrypt the secret recipient address on Juno and send it to secret, and then on secret, you will get that 10 atoms, but to an undisclosed wallet. So that's just an example. But yeah, maybe to also circle back a bit, I think like private voting is very, very important, especially in democracies. Like up until now on Secret, we could offer privacy as a service for payments mostly for other chains, but now with IBC contracts, I think we will see that we like privacy as a service on steroids, because the velocity that you can develop CosmWasm contracts is amazing. So it's hard to, I think of use cases right now, but I'm sure that in the coming months we'll see a lot of cool use cases with privacy and like against other chains pop up. So I'm really excited about it, and especially the private voting. Yeah.
And maybe a quick comment for anyone who's still listening. If you want to better understand some of these use cases and see how they work and read that out in a small article or blog, you can actually check out the Secret Labs Twitter. I think they've posted 3 threads over the past few weeks on different use cases, voting, random numbers, and I think one other one. You can quickly just check them out and see if you understand how privacy as a service basically will work over IBC. Will probably help understand some of the nitty-gritty details if you're interested.
Yeah, I think the random number as a service is also a pretty cool thing. Because if you don't, long as you don't need it, another chain doesn't need it right away, but say, okay, we will, like what's the thing Algorand is using, partition or something, or whatever. It takes a random subset of 10,000 possibilities and take a random subset of 100, right? So you're like, I don't need it right away. We just say at block height 50,000, we send a message to get a new random number, and when the request comes back, whatever that number it is, we use that one to decide the next group of people, right? And so sure, it might take it a minute to get the answer back. Doesn't matter. But the number could not be influenced by anyone else, right? No one can influence what the number is. So I think that's a really, really cool use case. Actually, you can build having this random number pinger is a really cool feature too, and the voting as well. And these are things you can't be done by IBC token transfer, right? And if you're a relayer doing it, you're effectively trusting that multi-sig to give you the random number, which is pretty lame. And with IBC, you can write a simple protocol saying, query random, and it basically the trust boundary is like you have your query contract on chain X, your receiving contract on secret, and then the validator set of both chains. So if either chain is forked, they can cheat you. But when they fork a chain, you're pretty screwed anyway, right? So as long as neither secret nor your other chain is forked, and those contracts aren't hacked, there's no one else that can influence it, right? So all these other ones like Chainlink, a lot of it is basically, I think, just a multi-sig in the end, or some quote unquote oracles. Magic oracles is basically just a bunch of staked people. We have a whitelisted set of people that have staked money on it. So I think having actually IBC protocol delivering random numbers is a very, very powerful thing, because it's like the next most secure thing of actually having random numbers in the block header itself.
People really underestimate the amount of applications which use random numbers. I mean, something like a gambling app like Raccoon, or a game, or I don't know. Those are maybe the simple use cases people think about, but even on a contract level, or indeed randomizing certain inputs or choosing who proposes a block or stuff like that, all requires random input. And the random numbers which can come from Secret Network are really secure, simply because you have this private entropy. So looking forward to, if it's a very simple solution and it gains just as much adoption as Chainlink, then it would be a really great service for the entire IBC.
Yeah, whenever you want to do a fair decision somewhere in your contract, you need randomness. Like on Secret, it's instant, but I think with IBC, we can like nail down the Chainlink UX, which I think is the best you can get. If you're not getting that random number in an atomic way. So yeah, random numbers are really cool. That's a really cool feature of Secret Network that not a lot of people talk about. But I guess with gaming on Secret, we're going to see that very soon.
Well, guys, I hate to cut you off, but we are at the top of the hour, and this is typically where we end our Twitter space. Ethan, it was great to have you with us. We might have to have you on for a future space after our CosmWasm V1 upgrade is live, and maybe we start seeing some of these new use cases take effect. Might be fun to have you back and discuss some of these things again.
I'd love to be back. It was great being here and great talking to you, Asaf, and happy to be back. And guys, follow me on Twitter if you want to, and I'll be dropping some more knowledge on IBC from time to time.
Sounds good. And we'll be back with Secret Spaces next week. We will be talking about the upcoming Masari and Cosmoverse conferences, so make sure you're here for that. Thanks everybody for attending. We'll see you next week.